Hi everyone, this is Kamal. Welcome to my channel Understand Tech here. In this video, I'm going to discuss about machine assembly and high-level language. Being a computer science teacher myself, I often look for teaching material which would explain these various programming languages in an easy to understand step-by-step manner. For teachers and students, if you are also looking for this type of materials, I would say, now look no further. In preparing this video, I have really put a lot of time and efforts, maybe not necessarily in preparing contents, but definitely on as what would be the best way of presenting and explaining these materials. Before starting, let me share this, that I have made few sacrifices regarding some technical accuracy in this video. Also, in many places, I have used simple words and languages rather than exact technical terms. The aim of both these things are to make things easier to follow and understand. Lastly, also, as I am trying to explain things from ground up, I ask for a little bit of your patience. So with this, let's start. Is a computer a living creature? Well, clearly not. It means it does not have a brain that it can think, reason, and take actions on its own. In fact, it can sense anything at all and do even the most basic things in its own. Hence, a computer does not do anything in its own. There are written commands in a computer. So, whatever we see happening in a computer, those things are happening according to commands in a computer. In other words, whatever we say computer is doing, it is doing things just following those commands. Perhaps you know, such a collection of commands is called a program. Further, a set of related program makes software. A person wants to add two numbers. As we just said, since a computer doesn't do anything in its own, a person needs to type the commands. Let's say he types, "Hey computer, find me sum of two numbers." Now the command goes to computer. But clearly, computer won't be able to understand the command written this way. So it's important to understand that a computer does not understand commands written in languages we humans use, like English. So the question is then, in what kind of languages, if we write commands, computer understands? Only language computer understands is binary language. Binary language, as the name suggests, is written using only two things, ones and zeros. So, a person sitting in his computer, instead of typing, "Hey computer, find me sum of two numbers," types a bunch of ones and zeros. Now, these ones and zeros goes to computer. And computer understands that it has been instructed to add two numbers. To understand anything related to computer, you should very clearly understand binary code. If you don't have a clear understanding of binary code, I suggest you watch my video on this topic. I have included the link to the video in the description section below. Okay, a person is sitting in a computer and, typing a random sequence of ones and zeros. Now, ones and zeros typed by a person reach to a computer. Does a computer understand things from this random sequence of ones and zeros? Does a computer understand things from this random sequence of ones and zeros? Of course not. So, it must be fixed what is represented by what combinations of ones and zeros. Let's say add, subtract, 5, 6, 7, etc. are represented by the following combinations of ones and zeros. Now, a person wants to add 5 and 6. Looking at the table, the person should type the following combinations of ones and zeros. Now, ones and zeros typed by a person reach computer. From these ones and zeros, computer knows that it had been instructed to add 5 and 6. Okay, a person is sitting in his computer and let's say he typed ones and zeros. Now these ones and zeros, as we said, have to reach computer. Ones and zeros is traveling. Sad thing is, ones and zeros cannot travel as numbers ones and zeros, as I just showed here. Since ones and zeros cannot travel as number ones and zeros, something must be sent to indicate 1 and some other thing to indicate 0, right? What can we send? The only thing that flows in a computer is current. So, you should send a certain type of current to indicate 1 and a certain type of current to indicate 0. So, what kind of current to send? Well, you send a current of certain value, like this one, to indicate 1, and not send current for some time, like this one, to indicate 0. So with this system, if 1 0 1 0 1 1 1 0 have to travel to computer, this type of current would flow. So ultimately, current representing ones and zeros reads to computer. In machine language, programs are written using ones and zeros. However, as explained before, this did not mean typing a random sequence of ones and zeros. In fact, it has to be fixed what to be represented by what combination of ones and zeros. Writing programs in machine language involve tediously writing lots of ones and zeros. If you were writing a program of some significant size, it would involve writing thousands and thousands, possibly even millions ones and zeros. So, so you can imagine how tedious it was writing program in machine language. Also, the other problem was it was very difficult to follow what the program written in machine language was doing. As when you look at the programs in machine language, you just see lots and lots of ones and zeros. So people were looking for an easier way of writing commands. In machine language, each combination of ones and zero represent certain instructions. For instance, in our example, a combination of 1010, 1110 represents add. People thought, instead of writing 1010, 1110, why not just write word add? So in assembly language, people started writing commands using words rather than ones and zeros. Note, a table that lists all commands that can be used and the combination of ones and zeros that represent them. So this table is called instruction set. Now, writing words instead of writing ones and zeros instantly made writing programs much easier. Also, it was a lot easier to follow what the program is doing. But however, even though we write words, they must be ultimately converted into ones and zeros. For this, people developed a thing called assembler that converted words written in assembly language into sequence of ones and zeros. Note, even if we write words in assembly language, ultimately that reach computer is ones and zeros. What happens if you write instructions that is not in instruction set? Let's say you write sum. What happens? Assembler looks at instruction set, it won't find sum there, and as a result, assembler won't be able to convert sum into sequence of ones and zeros. If anything can't be converted into sequence of ones and zeros, well, computer is not going to understand that thing. Now let's discuss why assembly language is called assembly language. What does assembly means? Collections, right? Now, isn't word add just a name to an assembly or collections of 1010, 1110 in our example? Words like add, shop, in an instruction set, it's just a name given to assembly or collections of ones and zeros. That's why name assembly language. Writing programs in machine and assembly language requires a detailed hardware knowledge. For example, if you want to write program for microchips PIC 16F873X microcontroller, you need to understand its architecture shown in this diagram. Whoa. Have a look at the diagram carefully. Definitely not average Joe's cup of tea. Think about driving a car. Where to drive a car, knowing about steering, brake, etc. is not enough. Instead, you need to understand all its complex inner working. You might say, complex inner working details is for car mechanics. Why for me? Well, If you want to write programs in machine and assembly language, you have to be like a car mechanic. You need to understand complex inner hardware working details. This is a program written for a 32-bit Intel processor which displays Hello World in a screen or console. Now, compare this to program written in high-level language like C. I should perhaps ask you which program is easier to follow. So definitely programs written in high-level language like C. So in an assembly language, just to do simple things like displaying Hello World, it involves writing lots of commands for different internal parts. Because of these, assembly language is also called hardware-oriented language. For the same reasons, assembly along with machine language are also called low-level programming language. High-level programming language frees you from this problem. In such language, you can focus on, what needs to be done and not worry about complex internal hardware details. This was one of the questions in the university exam. It was asked, what does the program do? Well, I don't have any idea. What about you? This is a program written in C language. You haven't studied C language? No problem. But can you try to find out what this program do? Well, it looks like it finds the larger among two numbers. So from these two examples, you can tell it's not only very difficult to write programs in machine language, but also very difficult to follow what the program is doing. On the other hand, high-level programming languages like C looks as if it is written in languages we humans use, like English. It also allows us to write things in somewhat the way we write in mathematics. This makes learning and writing programs in high-level language a lot easier and faster. Nowadays, almost all programs are written in high-level languages. Here a person wants to write commands to computer. Let's say this is a type 1 computer. This is an instruction set for this computer. As described earlier, an instruction set lists all assembly language commands that can be given to a particular computer along with the combination of ones and zeros that represent those commands. Let's say this is a type 2 computer. This is an instruction set for this computer. Of course, instruction set of this computer, is going to be different from the instruction set of type 1 computer. Why? Think about this. Let's say the manufacturer of type 1 computer is an American company. It has decided to call, say, addition operation add and represent it by 10101110. Now let's say the manufacturer of type 2 computer is an European company. How can you expect the manufacturer of type 2 computer to give the addition operation the same name and the same combination of ones and zeros to represent it? This is why, instruction set of different types of computers are different. Now a person wants computer to do addition and types add. Computer don't understand command directly. It needs to be converted into ones and zeros. This is the job of an assembler. Hence, command add goes to assembler. Now, assembler looks at instruction set table and finds that this sequence of ones and zero represents add. Hence, add is converted into this. Now this combination of ones and zeros goes to computer. From this, computer knows that it is being asked to do addition. What happens when command add goes to type to computer? There is also an assembler in type to computer. Commands add goes to assembler. Now, assembler looks at instruction set table. But there is no command having name add. Hence, assembler is unable to convert command add into ones and zeros. Note here, if a person has typed sum, this would cause type 2 computer to perform addition operation, but type 1 computer would not be able to understand this command. Hence, assembly language command written for one particular type of computer won't work in another type of computer. That's why assembly language programs are machine dependent. Let's say here a person wants to write commands to computer, but this time in high level language. Let's say this is type 1 computer. This is a set of compilation rules for this computer. A compilation rules specifies how commands is to be converted into ones and zeros. Let's say this is type 2 computer. This is set of compilation rules for this computer. Of course, compilation rules of this computer is going to be different from the compilation rules of type 1 computer. This is the key thing to understand here. Different compilers for different types of computer. To be more accurate, different compiler for having different computer architecture. Now, a person wants computer to do addition and types A plus B. Computer doesn't understand commands directly. It needs to be converted into ones and zeros. This is the job of a compiler. Hence, addition command goes to compiler. Now, compiler looks at compilation rules and following the rules here converts addition commands into this. Now, this combination of ones and zeros goes to computer. From this, computer knows that it is being asked to do addition. What happens when command A plus B goes to type 2 computer? There is also an compiler in type 2 computer. So command A plus B goes to compiler. Now compiler looks at compilation rules and following rules here converts addition commands into ones and zeros. Note, combinations of ones and zeros created here will be different from the combinations of ones and zeros created in case of type 1 computer. Now this combination of ones and zeros goes to computer. From this, computer knows that it is being asked to do addition. Here, a person has written command only once, but this command has worked for both computers. That's why programs written in high-level languages are machine independent. A file containing commands initially typed by a person is called a source file. As described above, a compiler creates a file containing ones and zeros from a source file. This file is called object file. From an object file, A final file which is ready to be executed is created, and this file is called executable file. The executable file created for type 1 computer contains different combinations of ones and zeros than executable file created for type 2 computer. Source file written in high-level languages are machine independent. Executable files are not. People often miss this point. Now finally, let's talk about advantages and disadvantages of each programming languages. Let's start with machine language. Advantages: in comparisons to programs written in other languages, programs written in machine language tend to be small in size and also executes faster. Since programs are already in ones and zeros, they can be directly understood by hardware and therefore do not need to be further translated like programs written in assembly or high-level languages. Disadvantages? Well, many. First, it's extremely difficult to write programs. It requires a detailed internal hardware working mechanisms, that is, architecture of a computer for which you want to write programs. A program can contain thousands or even millions of ones and zeros, depending upon its size. Hence, it takes a lot of time to write programs, and of course, writing thousands, millions, ones and zeros is definitely very tedious as well. If there are any errors in programs, because all you see is ones and zeros, it's very difficult to look at them. Programs are machine dependent. It means programs written for one particular type of computer will not run in another different type. It means programmers have to develop many versions of program so that they would run in different types of computer. In fact, only short and simple programs can be written in these languages. Nowadays, hardly any people use this language to write commands. Now, let's go to assembly language. Advantages: in comparisons to writing programs in machine language, writing programs in assembly language is easier. Programs written in assembly language tend to be small and also run faster than programs written in high-level languages. Disadvantages? Again, many. Even though writing programs in assembly language is easier in comparisons to writing in machine language, it's still difficult in comparisons to writing using high or very high-level language. Hence, large and complex programs are not written in machine language. Just like machine language programs, assembly language programs are also machine dependent. Programs need to be translated into sequence of ones and zeros using assembler. Now finally, high-level language. Advantages: it allows us to write programs using English-like structures and mathematical notations. This makes writing programs easier. High-level languages frees programmer from having to know a detailed understanding of complex architecture of computer. Programmer can focus on problems to solve which they are writing programs. The writing, reading, and understanding of programs in high-level languages are far easier than machine or assembly language. Also, it is far easier to locate errors and correct them. Programs are machine independent. This is one of the biggest advantages of high-level language. Unlike in machine or assembly language programs, programmers do not need to develop several versions of program for different types of computer. So definitely lot less work. Disadvantages, yes, few. Often programs do not make the most efficient use of processor and memory, hence program executions may not be as fast as machine or assembly language programs. Programs need to be translated into sequence of ones and zeros. This task we discussed earlier is performed by translator like compiler or interpreters. So how was the video? I hope you found the video informative and helpful. If so, please don't forget to hit like buttons and share this video. I would be posting videos like this on various computer technology topics, so please consider subscribing to my channel. So this was for today. It was a long video, so thank you so much for watching this video and see you in future video. Thank you.